good morning, good afternoon, good evening. Glad to have you today for another video tutorial. Today's topic is exponents, square roots, and perfect squares. So get out your composition book and let's take some notes, okay? So what are exponents? All right, so you probably know an exponent is that little number above a bigger number. Yeah, so you've got a little number above a bigger number. Well, this little number is called the exponent, or it's also called the power, and this is your base, 2. So a lot of people, when they see this, they say 2 to the 4th power, but that 4 is your exponent. But you usually hear it as 2 to the 4th power. So what does that mean? What are exponents? Exponents just means how many times you are multiplying the base number to 1 by. So when you say 2 to the 4th power, you're taking the number 1, here's 1, and you're multiplying it by 2 4 times. Now some of us think, well, the product is 8. 2 times 2, 4, times 2, 8, times 2, 16. 2 to the 4th power is really 16, okay? But that's exponents. It's just the number of times you're multiplying that base number by 1. So when you see something like this chart right here, okay, let me actually erase some of this stuff right here. Okay, so that's why I used to always get confused by this, but they would tell me, a math teacher would tell me that 2 to the 0 power is 1. And I was always like, well, I don't get that. Because how many 2's are you multiplying to 1 by? None. See, there's 0 of them. So you just have 1. So it's just 1. And 2 to the 1st power, again, it's how many 2's you're multiplying to 1 by. Well, this time you're only multiplying 1 2 to 1. So you get 2. 2 to the 1st power is 2. 2 to the 0 power is 1. Why? Because how many numbers of 2's are you multiplying to 1 by? None. Okay. 2 to the 2nd power, well, that would be, oops, got to raise my finger when I do this. That would be 4. And 2 to the 3rd power, well, that is 8. Again, it's the number of 2's you're multiplying to 1 by. Okay? Now, if it said something like 3 to the 3rd power, it's the number of 3's you're multiplying to 1 by. So here's 1, and it's going to do it, multiply by 3 3's, and you get 27, because 1 times 3 is 3, times 3 is 9, times 3 is 27. Okay, moving on. So now we're going to move to your roots. We're going to get down to your roots, okay? So when raising a number to the 2nd power, you also sometimes people refer that to as squaring the number. So when you see this, 10 to the 2nd power, well, some people will say, well, that's 10 squared. Or if I write something like this, 3 to the 2nd power, some people will say, well, that's 3 squared. Or 4 to the 2nd power, well, that's 4 squared. So whenever you have something raised to the 2nd power, some people refer to as squaring that number. And why? Because when you think about a square, if this was a square, remember both sides equal. So if this is 3 by 3, 3 to the 2nd power is really 9, right? And so 3 times 3 is 9. So that's why they call it squaring the number. And then here it says square root. Well, that's basically the opposite of squaring a number. So when you are looking at a number and you're asking what's the square root of that number, you're thinking about what's the dimension of one of the sides of that square. For example, first of all, well, this is the symbol to square root. And so if I have this symbol and 100, and I know it looks like a division box, but it's really asking this question, what is the square root of 100? Well, you're really just asking this, what times what, that's the same number, is 100? And that would be 10. So 10 squared is 100, therefore the square root of 100 is 10. Hope that makes sense. Just like 9 squared, well, that's 81, because 9 times 9 81, right? So what's the square root of 81? Square root of 81 is 9. So just write this down. This might help you just memorize what we just discussed. I'll give you a minute to do this. Okay. Something else to discuss is what's a perfect square? A perfect square is when you take a whole number, okay? Remember we talked about counting numbers, or not counting numbers, natural numbers, and then whole numbers. So when you take a whole number, which could be 1, 2, 3, 4, 5, and you multiply it by its same number, like 9 times 9, now you have a perfect square, which is 81, all right? So 9 is a perfect square. 16 is a perfect square. Why? Because 3 times 3. 25 is a perfect square because 5 times 5. 36 is a perfect square because 6 times 6. 49 is a perfect square because 7 times 7, right? So can you give me another perfect square? Just give me another one. It's easy, easy cheesy. And how to find the square root. Why is this back here? Okay, so yeah, I forgot. So there's a couple of methods. How do we find the square root of a number? Let's talk about that. How do we find the square root of a number? Well, you could just know your math facts, right? So what's the square root of 100? What's the square root of 110? What's the square root of 81? 9, right? Just knowing your math facts, because you're really asking this question. What times what is 81? That's the same digit. What's the square root of 49? 7, right? Because you just know your math facts. So one method is just knowing your math facts, but sometimes you're going to get to a number that you don't know your math facts for. For example, 225. Some of you guys might not know what times what is 225. So one way of finding the square root of a number is do the Christmas tree, do the prime factorization. So here, 225, I can factor that to 5 times 45, and then I can factor 45 to 9 times 5, and then I can factor 9 to 3 times 3. And then what you're doing now is you have 2 5s and 2 3s. We have our prime numbers. So I can write this as 5 times 3, right? There's 5 and there's 3, times 5 times 3. Well, that's 15 times, whoops, I have to lift my finger. 15 times 15, which that's the square root. 15 times 15 is 225. So let's just try that again. Let me show you again what I'm talking about here. A different method. So let's just say you have, what was I going to use on this one? Oh, let's try 324. So you have the number 324. So let's prime factor. Well, I know that number is divisible by 4. Why? Because the last 2 digits is divisible by 4. So 4 times what? Well, I could just divide 4 into this. I think I could do this in my head. You probably can do it. This 4 goes into 32, 8, and then 4 goes into 4, 1. So 81. And then we factor this to 9 times 9. And then we factor 3, 3, 3, 3, and we factor. Now we just find all of our pairs here. So here I have a 2, I have 2 2s, I have 2 3s, and I have 2 3s again. So you see those pairs? Or maybe I should write it like this. I have 2 2s, 2 3s, and 2 3s. So I really have 2 times 3 times 3 as one set times, I'm going to run out of room here, 2 times 3 as the other set. Well, now just do the math. This is 6 times 3, so I really have 18 times 18. So what's the square root of 324? Again, this is what we're trying to find. What's the square root of 324? 18. So again, the methods are, you can use your math facts, but sometimes you're going to get to a number that you don't, you can't use your math facts. So then you can prime factorize it and then just group the pairs together. Hope that makes sense. How much time we got left here? What are we at? 9 minutes. This is getting kind of long. This video tutorial is getting long. I'm at 10 minutes already. Okay, so just give me the square of each number, okay? I want you to do this, just give me the square. So this says 13 to the second power, or 8 squared, so just tell me what it equals. And then here, give me the square root of each number. So we just discussed this. Some, you can use your math facts, right? Some, you're probably gonna have to use that Christmas tree method. And here, just give me the approximate square root of the number, okay? Because there's lots of numbers, you can't give me the exact square root, but you can give me approximate, right? So like 145. So just think, what times what is close to 145? That's the same number. And that's it. So sorry about the tutorial going a little past 10 minutes, but I hope you enjoyed today's lesson, and I will see you tomorrow.